Welcome back to another example of solving a linear first-order differential equation. For a quick review, the first step is to put the differential equation in this form here, the standard form of a linear first-order differential equation. Next, we want to find the integrating factor, which is mu of x equals e raised to the power of the integral of p of x integrated with respect to x. Again, notice that p of x is the function here being multiplied by y. So once we find the integrating factor, we're going to multiply the differential equation by mu of x, which we see here. Once we've done this, the left side of the differential equation, this side here, is always going to be equal to the derivative of the product of mu of x, the integrating factor, and y. So if these two are equal, then we can set this derivative equal to the right side of the differential equation, which will be mu of x times f of x, or the integrating factor times f of x. Once we do this, we integrate both sides and solve for y. So let's take a look at our example. First, we should recognize that the given differential equation is in the correct form and all the terms are in the correct positions. Notice the first term is y prime, which is the same as dy dx. So next we want to identify the function p of x, which is being multiplied by y. So in this case, p of x is equal to cotangent x. We're going to use this function to find the integrating factor given by this formula here. So mu of x is equal to e raised to the power of the integral of p of x, which is cotangent x dx. Now we'll go ahead and integrate. We could write this as cosine x divided by sine x, then integrate using substitution, but we'll go ahead and use the integral formula for cotangent x. This would be e raised to the power of natural log sine x. And now here, because we have e raised to the power of natural log, which is also base e, this simplifies nicely to just sine x. This is our integrating factor, mu of x, which means now we're going to multiply everything in the differential equation by sine x. So we'll have sine x times y prime plus sine x times y cotangent x. I'm going to write this as sine x. I'm going to write cotangent x as cosine x over sine x, so we can simplify this if we want. Times y must equal sine x times 2 cosine x, or 2 sine x cosine x. Again, we can see here that this is going to simplify. This is sine x over 1. Sine over sine simplifies to 1. We don't need to do that, but we might as well. Because remember, the main idea here is that this left side of this differential equation, this side here, is now equal to the derivative of the product of mu of x, the integrating factor, which is sine x and y. So this derivative is equal to this sum in the yellow box, which is also equal to 2 sine x cosine x. You may recognize 2 sine x cosine x as a double angle identity. This is equal to sine 2x. So let's go ahead and write this one more time. This derivative is equal to sine 2x. Now we're going to integrate both sides of this equation with respect to x, and then solve for y. Let's go ahead and do that on the next slide. So integrate the left side with respect to x, and the right side with respect to x. So the integral and derivative will undo each other, so we're going to be left with sine x times y must equal the integral of sine 2x. Let's be a little careful here. That's going to require a u substitution, where u is equal to 2x, differential u is equal to 2 dx. So if we divide both sides by 2, we can see that dx is equal to 1/2 du. So if we wrote this in terms of u, we would have the integral of sine u And again, dx is equal to 1/2 du, so we have this extra factor of 1/2. So on the right side, we're going to have 1/2 times the integral of sine u is going to be negative cosine u, or negative cosine 2x, and of course plus our constant of integration. Now to solve for y, we'll divide both sides by sine x. This simplifies nicely to y. Let's be careful on the right side. We're dividing both of these terms by sine x. So for this first quotient, notice how we're going to have a negative cosine 2x. This 2 here is going to join the sine x in the denominator. And then we're going to have plus the constant divided by sine x. We could write this as c times cosecant x as well, but we'll go ahead and leave it in this form. We'll go ahead and stop here for this example. I hope you found this helpful.